Well, welcome to this video on an introduction to lunar astronomy by me, Mr. Powell. Here we've got a few pictures that I've taken of the moon with my new telescope. You can see all sorts of detail with the craters and such like, so I thought I'd go through and explain to you what I've been doing. So firstly, if you want to explore space, why not think about buying a pair of good binoculars maybe to start with. That would be about £60. You need some with some quite good magnification. Or you can buy a cheap reflecting telescope such as this one. This one was £150. This was my telescope that I bought recently. It's a Power Seeker 127EQ telescope. There are lots of manufacturers of telescopes. You need to be aware though that some of them are just too cheap and too poor quality to do the job. This really, I think, is about the limit of the bottom of where you should be looking at. It's got a very sturdy tripod, but even with that tripod, in the wind, there's definitely a bit of shake. You've got these special dials here, so you can dial either left or right viewing, or up and down effectively, or change your angle of view. Very easily to dial them. If you see a telescope and it doesn't have these two adjustment dials, you see there the angle can be changed easily. Forget it, because you cannot look properly and carefully. You will not be able to set the telescope up correctly. There's also a counterbalance weight, which is really important in the case of a telescope, because that counterbalance means that when you move the telescope itself becomes very lightweight. So we're using a sort of a moments effect, a balancing point. With this telescope, the light comes in through this opening here, and it reflects off a parabolic mirror at the back. We're going to explain that in a second. And it comes back up again, and this array here, effectively, there is another reflection that takes place, and the light goes into an eyepiece that you look through the side. Up here on the side is just a view scope to help you initially find your image. It's also important to think about, if you buy a cheap telescope, this viewfinder will never actually line up with your telescope, and they're no good. So let's just have a look. I've taken a picture here off Wikipedia on the reflecting telescope, so you can always go and look in more detail. But really, I just wanted to keep it simple. So this is the schematic of my telescope inside. So this is the parabolic mirror at the rear. It was first made by Newton, so it's called the Newtonian telescope, and it was the first successful reflecting telescope, and it was made in 1668. So that's actually quite recent. It uses the parabolic mirror. This is the primary mirror, and avoids the problem of using a circular mirror where the rays don't all focus on the same point. So figure B shows this. So that this is a mirror picture. So it's the same as with mirrors as it is with lenses. So here we've got a lens idea, and a perfect lens should focus everything to the same point, and so should if we had a mirror. However, mirrors that are properly circular, just as lenses that are properly circular, actually end up with lots of different focal points, and it's a little bit staggered, this, but what ends up happening is you get a bit of a fuzzy image. So what we need is a very nice parabola here. That costs more to make than a circular one. So the light is collected, so it comes in through the end of the telescope. It's collected onto an angled mirror, so clearly you sort of can't see this point here, so we do lose a little bit of light, which is a flaw in the design. But most telescopes now, the really big ones, are all made on the same idea. And then the purple lines show the point, the focal plane, don't they? Now here we've got the sort of the where the image will be formed. We've got the focal point, and then the green rays are sort of coming out. So we form a picture with lots and lots of focal points along from different positions where the light's coming in. The features are good with this telescope because it's quite a short telescope for the magnification that you can achieve. And here, of course, we can also add whatever we like in terms of optical lenses to produce magnification and focus via refraction. You can also put coloured filters on, which also help. Now, if you don't have binoculars or a telescope, you can also think about, just as a cheaper option, on Android in particular, I think, and Apple will have similar, the Google Sky Map application, which gives a 3D view. You can click on the stars and the constellations and the planets and just point it at the sky. That's really quite good, especially if you are not quite sure what you're looking at. You can always find the planets this way in the morning or the evening. There's another good app as well, and that's the BBC News app, so that's easily downloadable, and you can have lots of physics articles or science. This one was really cool because it was all about looking at tracing the sunspots using the Kepler telescope, and they worked out that in fact our star, our sun, is 4.6 billion years old, and it's all due to its spin period, so it's really clever. They were talking about that the sun-like stars in a freshly studied cluster sit squarely and satisfying in the gap, spinning about every 18 days. So then they were looking at other stars and how fast they were spinning. So you can all download those two for free. There are lots of apps around. Now then, well, what did I see? Well, this was a picture taken with my telescope, so we can identify the Kepler crater. So there's a crater. The Copernicus crater here. The Tycho crater. It's not in great focus there. I think I've got a slightly better picture coming up. The Sea of Nectar, Sea of Crises, Sea of Tranquility, Sea of Serenity, and Sea of Showers. So all of these were originally seas, so they are lower and darker. The reason they look quite dark is also because the moon is mainly, I think, made of basalt on the surface, which is a darker rock. But quite a good picture for a 5-inch reflector. Here you can see I think the Tycho crater in a little bit more detail. Sea of Moisture, I think the Ocean of Storms, and then those two seas. And we're on a south to north basis, so the north is here. So sort of upside down in a way. Oh, we'll go one more on. Now this one, it was the same type of picture, but I used what's called a Barlow lens, and my Barlow lens is a 3 times magnifier. So compared to the previous picture, we can really see the definition, can't we, on this crater and this one, and all these craters in really good relief, and they're absolutely massive compared to the Earth. This is an absolutely battle-scarred sort of lunar body as such, or I almost said planet, but we know it's the moon because it's orbiting our planet. Now this is one that I didn't take, but it's fairly impressive. This was taken by the Apollo 17 crew, so some time ago. Formed 4.3 billion years ago. The diameter is equivalent, so going all the way across there from London to Athens, or about 1,600 miles. It's 6 kilometres deep in some places, and on Earth our craters are only sort of 1 to 300 metres deep in sort of magnitude. That's because, of course, think about it, the moon doesn't have any atmosphere, so it just, anything that impacts just goes straight in, whereas anything coming through the Earth's atmosphere mainly burns up. So I will leave you now with this picture of a detailed study. So this has come again from Wikipedia, this one, and this goes through all of the features. But I think my picture is in slightly better detail, but they've got an awful lot of detail there on the different seas. So now the question is, what can you find on the moon, either by just looking at it, or you get your own telescope, or you can buy some straightforward binoculars. Thank you.